Hello, this is Chris Beasley again, and this is part 3 in a series of videos related to the Sequence Wizard. I encourage you to watch the other 2 videos related to the Sequence Wizard before watching this one because I'm not going to explain the basics in this one. What we're going to do today is we're going to see how you can define a variable and allow that variable to propagate through a series of steps. So over here on the right, I've defined a sequence where initially we're going to run an open circuit. Then we're going to loop several times between polarization resistance and potentiostatic EIS. Once that loop would be done, then we're going to run a long-term potentiostatic experiment followed by a potentiodynamic experiment. So, as I said, we're going to be using variables, and one of the convenient ways that you might use a variable is defining an area. So if I click here on define area, I drug this over from the available steps. I might name this variable area, and we can define it. There's 3 different variable types: potential, reals, and integers. In this case, I want to make it a real, and I can assign it a value at this time, or I can modify the variable right after this step or in subsequent steps. Now, by default, maybe we're using 1 square centimeter. Now, you'll see that there's no units here, but that's okay because you'll see when the units come into play. Okay, so I've defined a variable. And I've set an initial value. If I wanted to modify that variable right away, I could drop the modify variable step right in after it, double click it, then I can choose area and then modify it. Okay, so let's cancel that for the moment. Next, we're going to run an open circuit, and we're going to loop based on cycle number. Inside polarization resistance, inside the loop, we have polarization resistance, potentiostatic EIS. You set the parameters up normally, but perhaps in sample area, now we click on this little, it looks like a gear there, and now I can choose a variable here, and I can choose area. And we can see that the input box has now been grayed out. So whatever variable you put in, whatever value you put in the variable initially is what gets dropped in here. We can click OK. Then we can move it on to potentiostatic EIS. You input your typical parameters, but now you can choose area. And the same with your other steps, potentiostatic and potentiodynamic. And now, whatever value we have in this variable here will get propagated through the rest of your steps. Okay, so that's a really easy way to use a variable and allow it to propagate through the steps. Now we're going to look at another way to use variables. In this instance, I have a different sequence here, and I've made it a really simple sequence. I'm just going to loop a series of cyclic voltammograms with an increasing vertex potential. So I've defined a variable, and in this instance, maybe I'll just name it vertex potential. I'm going to choose type potential, and I can define a potential versus EREF or versus open circuit. In this instance, I'm going to just make it 0.5 versus EREF initially. So perhaps you'd have a typical 3 electrode cell setup. Now I have a loop based on a variable. I have to double click on that, choose the variable name. I'm going to call it vertex potential. And this loop is going to go until one of these conditions is met. I can define a less than or equal to, greater than or equal to, or not equal to. And in this instance, I want to loop based on an increasing vertex potential until it becomes greater than 1.5 volts. Then I set up my cyclic voltammetry, and scan limit 1 is where I'm going to define my vertex potential. So I'm going from 0 to my vertex potential, as you can see, and then I'm simply going to loop back to 0. Click OK, and now the CV will run from 0 to whatever the vertex potential was defined as initially. After that, I can increase my vertex potential by modifying the variable. I choose vertex potential, and then I can add, subtract, multiply, or set a variable equal to a certain value. In this instance, I want to add 0.1 volts every time we run through this loop. I click OK, and now what would happen is that we would run a series of CVs starting with a vertex potential of 0.5 volts up until it was greater than 1.5 volts in 100 millivolt increments. I have one more feature that I want to show you regarding variables in the sequence wizard today. This example doesn't utilize loops at all. What this is going to do is we're going to use a variable that's already been defined in the sequence wizard. This sequence is very simple. It has linear sweep followed by potentiostatic EIS. Now, typically, if you were going to run a series of experiments like this, you would run linear sweep from some initial value to some final value. And then if you were going to run potentiostatic EIS right after that, you would most likely want to run potentiostatic EIS at that final value, at that final potential. So we'll define linear sweep, some initial parameter, some initial potential to some final potential. And then in potentiostatic EIS, we don't necessarily have to define the final potential here. We can simply click on VLast and it will get grayed out. And so now that VLast will be passed in from the previous step linear sweep voltammetry. And as we saw in the setup, we swept potential from 0 to 1 volt, which means we're going to run potentiostatic EIS at 1 volt. And so we click OK and we can go ahead and run our sequence. Thank you for your time.